Hi everyone, I'm Akanksh and I'll be explaining our embedded project today. We have built a smart distance detection system using the AT89S52 microcontroller, which is an 8051 based MCU. It forms the core of our circuit and controls all the peripherals. We used an external 11 MHz crystal oscillator in the development board for stable timing and accurate delay generation, which is essential for ultrasonic distance measurement. Though some variants of the 8051 family have inbuilt oscillators and capacitors, in our case we used external 33PF capacitors along with the crystal to ensure proper clock operation. The microcontroller receives data from the ultrasonic sensor and drives output in devices like the LCD, buzzer, LEDs, and matrix display. We connected a 5-volt regulated supply to power the board using the Arduino. For programming, we used an Arduino Mega acting as a USB programmer. The Arduino is connected to the AT89S52 via the ISP. The pins in the ISP are master out slave in, which is used to send data from Arduino to the microcontroller, and master in slave out, used to receive data from the microcontroller. Serial clock, which provides the clock signal for synchronization. Reset, which resets the microcontroller before programming. And VCC and ground, which provide power and ground connections respectively.
Hi, I'm Arvind. I'm here to explain our project's distance sensing and alert system components. We use the SC-SR04 ultrasonic sensor where the trigger pin is connected to port 3 and second pin, and the echo pin of port 3 and third pin of the microcontroller. The sensor works by sending a short pulse through the trigger pin and measuring the time it takes for the echo signal to return. This time is used to calculate the distance of any nearby object. Based on distance, we designed a simple yet effective alert mechanism using a buzzer and 3 LED connected to port 1. If the object is very close, below 5 cm, all LEDs blink and buzzer beeps rapidly. Between 5 and 10 cm, 2 LEDs blink and the buzzer slows down. Between 10 and 20 cm, only 1 LED blinks slowly. And if the distance is more than 20 cm, all indicators stay off. This setup gives us a clear and intuitive visual and audio warning system, making it easy to judge proximity at glance.
Yeah, hi everyone, my name is Prasanna and today we'll be discussing about the output display system. We are using a 16x2 IC2 LCD and uses less ports compared to the normal ICD. And you can see this I2C chip over here. And the ports are connected to P06 and P07. P06 to the serial clock and P07 to the serial data. And other nodes, other ports are connected to the ground. Yeah, and then we have used the matrix 8x8 LED matrix with max 7219 driver, which is connected to the port 2. And the pins here, there are 3 pins which are connected and to the port 2, and one is for data in and chip select and the clock. Yeah, and this matrix, the matrix display changes according to the distance, and here's the demonstration for it. Yeah, you can see the stop symbol over here when it's less than 5 cm, and when it increases, you can see the thing changes. This is for more than 5 and less than 10, and this is more than 10 cm. You can see the display over there, and this is more than 20.
I'm Kaushik and I'll be explaining the code. The function I2C start initiates I2C communication by generating start condition. The function I2C stop terminates I2C communication by generating stop condition. The function LCD slave sets the I2C address to communicate with the LCD. The function I2C ACK waits for the ACK bit from slave device. The function I2C write sends a byte 8 bits serially through I2C. The function LCD send commands like clear cursor move to LCD in a 4-bit mode. The function LCD send data sends character to display on LCD. The function LCD sends strings to LCD by sending 1 character at a time. The function LCD initializes the LCD with appropriate commands. The function LCD delay MS creates a delay loop by nesting loops used for timings. The function send trigger sends a 10 ms trigger plus to ultrasonic sensor. The function measure distance waits for echo pulse, starts timer and measures the time duration, and converts time to distance in CM using formula distance is equal to time divided by 59. The function into string converts numeric distance to a string to be printed. The function pulse CLK creates a pulse on CLK line. The function send byte sends 8-bit serial data to max 7219. The function max 7219 command sends a register address and data to max 7219. The function max 7219 initializes, and the function max 7219 display pattern sends 8-byte pattern to 8 rows of matrix. We are done with the function initialization, and these are the declarations for emojis.
and these are the function calls for function initializations. And the function show alert shows the following. And the function main void show, function show alert shows the breakdown less than 5 cm, all 3 LEDs on, buzzer on, emoji close, blink fast. 5 to 10 centimeters, LED 1 and LED 2 plus buzzer on, emoji near, medium blink. 10 to 20 cm, only LED 1 plus buzzer on, emoji medium, slow blink. Greater than 20 centimeters, all LEDs off, buzzer on, could be set off, emoji far. And the main function shows sets LED LCD address, initializes LCD and LED matrix, sets timer 0 mode for ultrasonic time counting, displays distance on LCD, enters infinite loop, measures distance, converts and displays it, calls show alert to update LED buzzer emoji.
This is Nitin. I'll be explaining the whole code flashing part to the using Arduino and the 8051. And first, after making the C file, after coding the C file, go to the projects and go to the options for target and select the X frequency and go to the output and check the tick the checkbox for the hex file and click OK and go to translate, rebuild and rebuild, and the file will be saved at this location. Go to Windows C and go to Keil B5 and go to C51 and go to examples, and that will be having hello, and the objects will be having the file. This is my file name which is saved at 8:35 and the time is around 8:35, and copy to the location which you have defined in the terminal. I have defined it in the downloads file, so go here and save it, and after that go to the terminal. Before that you should flash the Arduino as an ISP, and now flash the code. After you should select the ports, which is I'm using Arduino Mega, so I've selected Arduino Mega over here, and the COM port is COM5, and yeah, the code is flashed. Done uploading, and now after saving the hex file in the downloads directory, we'll run the command at the terminal, which contains the exe file, which is the tool responsible for communicating between Arduino and the 8051 through ISP interface. And this is the configuration file, which has the detailed information about the digital signatures and the flash memory sizes, which we could see it over here. Our series is 89S52, and it is defined here, and these are the digital signatures which is responsible, and you could also have the flash memory size, which is mentioned over here. And this is the STK500V1, which is this keyword is responsible for the AVR programming, and this is a COM port where our Arduino is connected. Our Arduino is connected through COM5, and this is the port where this is the microcontroller which we are using, 89S52, and this is the baud rate at which we are setting the program to be flashed and run. And this is the flash file which is put in the downloads directory, which is named as jk.hex, and right now we'll run the command. Now it is reading and writing. Now it's verifying. Now it's done running. Now the code is run. Let's see the output. Now we'll keep an obstacle which is in distance of 2 centimeters. Here you could see the density is high and the 3 LEDs and the buzzer frequency high. Now let's increase distance. Now distance is 7 centimeters, which is between 5 and 10. Now you could see the intensity is reduced and 2 LEDs are blinking, and the buzzer frequency is lesser. Now we will increase the distance more. Now it is 14 centimeters. You can see the intensity is reduced and 1 LED is blinking, and the buzzer frequency is very less. Now let's take the frequency off, and now there's no obstacle, and you could see the distance as 1 to 1 noise value, and the LEDs are not blinking, and the buzzer is also not